And now for the last but not least, the final keynote, the closing keynote for today is my dear friend Vishal Sikka. I've known Vishal for decades when he was the CTO of SAP. Then he went on to become the CEO of Infosys and then decided to do a startup. And now his startup is started before the AI craze happened. And by the way, his PhD is in AI. I won't mention when he got it. It was a couple of years ago. But he now is the CEO of Vian Systems. I hope I'm pronouncing it correctly. I know. Please welcome Vishal Sikka.
So everyone's still here. Everyone's still basically together. 2 weeks ago, MR called me. He was on his way to Princeton or somewhere. And he said, Vishal, why don't you come and do the closing speech and basically wrap up the day and do it in 15 minutes and talk about, 35 years in AI. I was sitting here with Neeta. Neeta and I were AI students here back in the 90s, right here at Stanford. It is, first of all, MR, thank you for doing this. This is an unbelievable event that you have put together. I think it is an extraordinary service to bring all this diversity of speakers and people here together in such a beautiful setting. This room, by the way, this is the faculty club at Stanford. This room is where the Nobel Prize winners are felicitated. This is where the Turing Award winners are felicitated, and so forth. So, okay, do we have how much time do I have? Do I still have 15 minutes or 20? Oh, okay. Can we?
Vishal, you have 20 minutes, no problem. You can take as much as you like. We're just lining up your presentation right now.
Okay. So I wanted to, there is a beautiful book on physics. It's called 7 Brief Lessons on Physics by a great physicist called Carlo Rovelli, Italian guy who teaches at the University of Marseille in France. So I thought about, how do you compress all this stuff about AI in a 10, 15-minute talk? So I decided to call this thing 5 Brief Lessons on AI. And I'll try to do this in 10 minutes and leave some time for you guys to ask questions. By the way, how many of you know about what is generative AI? Like, how does it work? How does ChatGPT do what it does? Okay. I was hoping to skip my first of these lessons, but then I think I'll do it. So I did my PhD here. A lot of people want to know about this thing I did at Infosys with OpenAI. We were the first corporate donors to OpenAI back in 2015, long before Satya got involved. And I was on their founding advisory board. So the thing about generative AI is that it is something that is quite powerful, obviously, but it is also extremely simple. And it behooves all of us to understand what it is. So I'll try to do in 2 minutes a quick lesson. So back in the early 90s, in fact, when we were students, neural networks were generally considered sort of on the fringe of AI. Now the AI that we studied is called good old-fashioned AI. So on the left-hand side over there, I have a picture of a very, very small neural network. This is actually a network that was built by a company called Fair Isaac back in the early 90s to do credit risk evaluations. It would take 4 parameters as input. I think the job duration, the amount of loan that somebody was looking for, and 2 other things. And then it would, predict whether this what the credit risk was. And the way it works is you have, let's say you have 1 million pieces of information on these 4 bits of information about 1 million different people and whether they were credit risk worthy or not in the past. And so you run through one of them. In the beginning, the interesting thing is that the network itself is not a collection of rules or anything like that. It is just a bunch of numbers. And the numbers originally are just random, so they spit out something which is, usually wrong. And so you look at the difference between what the answer should have been and what the answer is, and you propagate that backwards through the network. And then you do this over and over again over the 1 million samples that you have. And before you know it, miraculously, the thing predicts credit risk with a deadly accuracy. That's basically what these neural networks do. This particular one has 10 neurons, as you can see, which in today's parlance would be 23 parameters. There are 20 links and 3 biases. Fast forward to today, and the speaker before me was talking about a 70 billion parameter model. 70 billion, so that is what, 7 billion times bigger than this thing. ChatGPT, we don't know how many parameters it has. It is widely believed that it has more than 1 trillion parameters. Some reports say it is 1.6 trillion parameters, something like that. And what these parameters are is a bunch of numbers, like this thing up here. Some of you, if you can probably see that. This is actually a dump from Llama, from Llama 3. Thanks to Meta, we can actually look inside these things to see what is in there. Otherwise, the closed models are all closed. And you can see all the leaders in these things. But in the end, basically, what it is a massive neural network, trillion plus parameters or tens of billions of parameters that has been trained to predict the next word out of these giant amounts of data. These text corpuses like Wikipedia, all the books out there and things like that. And you keep doing that, and you keep predicting the word, the next word, and the next word, and the book itself acts as a giant training machine because you know what the next word is and what it should be and so forth. And after massive amounts of training, these things learn to predict with incredible accuracy what the next word should be. And so when you give it a prompt or a question, they generate this body of text, which to us looks like an incredibly articulate and coherent answer to the question or exposition of something. When all it is a massive distillation of this trillions of words and then a accurate prediction of the next word. So when you think about it like this, it sort of demystifies what is going on here. There isn't it is a machine that generates the next word and the word after that. It's an unbelievably powerful machine, but that's what it is. Okay, everybody with me so far? All good? The second point I want to make to you is, ignore all this bullshit about, sorry, are we allowed to say that? Having been around AI for 35 plus years, I would say ignore all the nonsense, I think that's a better word, about AGI and ASI and all that. I think it's all things that are designed to give us, dopamine hits of fear and excitement and greed and all of that. There is no AGI, there is no ASI. This is all nonsense. Focus instead on productivity gains. Life is easier when you think of it that way. We have had tools, now we use tools routinely. We are still people. Tools that our ancestors would have thought were absolute black magic, like the phones that we have in our hands and things like that. So, this is also from one of the image generators. The prompt was, imagine a horse, and out came this horse with 2 heads. Here at Stanford, we have the Center for Human-Centered AI, HAI, and every year we publish, I'm on their advisory board, every year we publish this index, AI index. It just came out last week. The one that came out this year talks about massive productivity gains that are possible. If you just look at what Utkarsh was talking about in Adalat, he is already able to achieve a 50% productivity gain in stenography-related tasks. The study by Eric Brynolfsson here at Stanford talked about, they actually examined call center productivity gains in quite a bit of detail. They found that the early employees, the junior most employees, were able to get 14% productivity improvement. And the more senior ones were able to get 34% increase in the number of issues that they were able to resolve in the course of a day. So not just the sheer productivity, but the productivity in the outcome was 34%. Now, revolutions are done on a lot less than 34% productivity gain. So please follow 2 truths at the same time. This stuff is not AGI. This is not close to AGI. It is an irrelevant question. And this stuff is incredibly disruptive and powerful and useful, and we can make good out of it. And both of these statements are true at the same time. Yeah? Okay. There are some more examples here. And I urge you to read this AI index report. It's actually an incredible condensation of what is going on in the world of AI. The third point I want to make is that hallucinations, like the two heads on that horse, are not a bug that will go away in transformer-based AI. It is an inherent attribute of this AI. It is a feature. And people sort of brush this over, but Sam himself said at Mark Benioff's conference that you have to think about them more as features than bugs. We have seen plenty of examples of, and if you have not, just read up on what kinds of things are hallucinated and how are these things. The AI safety, I think somebody asked the previous speaker from Meta a great question about safety. There was a paper recently by 3 researchers from Singapore which talked about how hallucinations are inevitable. They actually demonstrate that a transformer-based LLM will always hallucinate. So it's an inherent attribute of this technology that we use. It is guaranteed that in some circumstances it will make mistakes, it will produce them, because it has to generate the next word. It will make up the next word when it has no idea what the next word should be. And this will happen, and you can try it. A good way to try to get it to hallucinate in a very predictable way is to ask it about something that you happen to know a lot about. Every one of us is an expert in something. We generally, you ask something like, write me a poem in the style of Thomas Jefferson. Who the hell knows what kind of poetry Thomas Jefferson wrote? So it all looks like magical stuff to us. And it is, some of it is incredibly creative and powerful. But when you ask it about some factual things that you happen to know something about, in 3 minutes, 4 minutes, you get it to its knees and then it is spitting out nonsense. And it happens with every one of them, with Anthropic and ChatGPT and equal opportunity. And this stuff is dangerous. Daniel Dennett passed away last week. He gave this memorable quote in his last interview that he did. If we turn this wonderful technology we have for knowledge into a weapon for disinformation, we are in deep trouble. Because we won't know what we know, we won't know who to trust, we won't know whether we are being informed or misinformed. We may become either paranoid and hyper-skeptical or just apathetic and unmoved. Both of those are very dangerous avenues, and they are upon us. So the danger with this stuff is not that autonomous robots will show up and start to take our jobs and destroy us with massive lasers and all these kinds of things. It is that this kind of disinformation that shows up that is incredibly believable. And it is happening, and it will happen, and it will happen in the election season that is here around the world, in India, here in the US, in England. Everywhere there are, this year, 2/3 of humanity is going to vote in democracies. So this stuff is quite dangerous. So it behooves us to understand the limitations of it. One of the things that everyone specifically points out is this thing with price performance, NVIDIA, GPUs, and all of this stuff. It will improve, it must improve. This is again quite an incredible story. NVIDIA itself is an incredible example of how engineering excellence has propelled it to where it is now. Whether it is a bubble or not, and all of those things aside, there's clearly no doubt that NVIDIA's hardware is by far the best hardware for this stuff, and by all accounts will continue to be so, at least for several more years. A single chip inference performance in NVIDIA alone has improved by 1,000 times in the last 10 years. That's that graph. That is their own apples to apples comparison. Actually, it is less than 10 years. And yet, despite that, the amount of money being spent, the amount of energy that these systems consume is simply, we don't have words that are, adjectives that are big enough. It is ridiculous, it is unbelievable. Earlier today, I was at the Oracle board meeting. I'm on the board of Oracle, and we have, Oracle has a very large cloud business, and we approved a, not quite 100 billion, but we approved a massive data center spend for the next 2.5 years. Massive, tens of billions. Microsoft and OpenAI have talked about a $100 billion data center project. People are talking about reviving coal plants to power these things, nuclear power to fund power data centers. So this is just, it's quite, somehow it just seems like this is a bit too much, what is going on. On the other end of the spectrum, there's a beautiful picture of a hummingbird. So, you know, as I stand here, many of you must be hungry after spending the whole day in a knowledge-intensive kind of a session. We basically get by on 2,000 calories. That's about a 100-watt light bulb. So like one of these light bulbs is what keeps us going. Out of that 100 watts, about 20 to 25 watts goes into our nervous system, our brain. And that's 250 trillion to a quadrillion synapses, about 70, 80 billion neurons. A 100-watt light bulb. Someone did an analysis that's about 20 orders of magnitude more efficient. So 20 zeros. It's at least 1 billion times more efficient than today's computers, but there was a paper that some scientists also from Intel wrote recently that the estimate is that the animal brain's ability to process information is 10 to the power 20 more efficient. So, you know, and you can get by with 2 vada pavs with this intelligence. I think there is a lot of headroom here. By the way, this hummingbird, which can actually see better than humans see, gets by on 7 calories in a day. That's 1 almond. So my last point is, we have humans have been building tools forever. This is a beautiful, powerful new tool that we have built. Our main duty, our main responsibility here is to transcend this tool, like we transcend all tools. We make tools our own. And if there is one set of numbers that I want you to take away from today, it is this. There are about 8.2 billion people on the planet, give or take. Out of those, 180 million have ever used ChatGPT. So the difference between the people who have used and people who have not used is also 8 billion. So, you know, barely a scratch. Out of those, 2 million people can build you an AI application. 2 million. And these are not people who can build you ChatGPT. These are people who could build you like a classifier like I showed you for predicting fraud or when a machine is going to fail or something like that. Out of those, about 250,000, and I checked with Sebastian before I came here to make sure these numbers are more or less okay. He was the founder of Udacity. 250,000 people could operate a machine learning system, like ML engineers, people who run machine learning systems. And the number of people who could train and build a Llama or a Claude or a ChatGPT is less than 50,000. It's much less than 50,000. And there is this ridiculous war over this talent and massive amounts of money being thrown and things like that. So this thing has to change. And it is, yes, it is a problem of using and learning and playing around with it to see what it is. Yes, it is a governance and regulation problem. I was a little bit shocked by what one of the panelists earlier said about regulation and how regulation is a bad thing. Are you kidding me? I mean, I'm standing here knowing that this massive concrete block is not going to fall on my head because of regulation. That this roof is not going to collapse on us, these lights are not going to fail, and then somebody just shrugs and says, yeah, you know what? Regulations are a bad thing. Is this a joke? These things are incredibly powerful and damaging. Yes, they should be regulated. Absolutely, they should be regulated. Are you kidding? I mean, we get our hair, you know, worked on by barbers who have a license, for God's sake. Yeah, we need to understand these things. We need to govern these things. We need to learn and teach, especially in India. Otherwise, the 20%, 30% productivity improvement could have devastating consequences on a lot of services companies. So I think this is perhaps the biggest challenge, is that this technology is not a mystery to us, that it is in fact, something that we understand and we can use like other tools that we have learned to use over the millennia. To end, I want to take you back not to a few decades or even a few millennia, but this is does anybody know what this picture is of? There was this is the Cambrian explosion. So several 100 million years ago, that giant pink area that you see in the middle there, something strange happened. There was a giant, huge explosion of the number of species in the world. And it's very interesting. Only recently, last couple of years, people figured out why this happened. It was, back then, the Earth was basically covered with water, and it was very toxic water. There was no oxygen in the atmosphere. And oxygen was just starting to emerge. And it was dark under the water, so there was no need for eyes, to see. And the species began to, figured out that if you got out there, outside the water and into the sunlight, and you learn to see, you could live more easily, you can find prey, you could, hunt for things, and chances of survival and thriving were much higher out there with the ability to see. So, the ability to see, the eyes formed at that point. So the Cambrian explosion was really an explosion of sight, of vision, of our ability to see. And all kinds of eyes emerge, Up here, of course, we see in the front, there are eyes in the back, there are creatures with hundreds of eyes and round eyes that can see everywhere. And I think that maybe not in our lifetimes, but certainly in our children's lifetimes, we will see machines that are significantly more intelligent than what we have today. And I think this idea of humanity and what we are about and all of that, it is really about evolving and learning this ability to do a new kind of seeing, develop a new sense of vision, a new sense of sight. A ChatGPT understands in the perfect state, it understands everything that we have ever learned and can regurgitate that back to you, but also perhaps over time will be able to tell you what it means and what its consequences are and all of that. So our ability to see the unseen and imagine and create will continue to guide us forward. One of the panelists, Professor Sundar, was talking about the difference between data, information, knowledge, and wisdom. Some of you may know about this great book called Siddhartha by Hermann Hesse. We had a movie that was made with Shashi Kapoor about it. There is a beautiful line in this book. It is towards the end of his life, Siddhartha says to his friend in German, he says, Wissen kann man mitteilen, Weisheit aber nicht. It means knowledge can be communicated, but not wisdom. We have to find our own wisdom. And that pursuit is still ours. Thank you very much. Please.
See, the next frontier, they say, is combination of bio and AI, right? And I looked into cyborgs and stuff like that and actually read some videos. So my question is, very interesting point you raise about the energy consumption by hummingbird. Today, we have these chips taking so much consumption. Earlier in one of the panel, we talked about, to do 100 queries, you're using 1 bottle of water or something like that. What if will there be a situation where we start tapping into brains? Because cyborg is not just human, right? Cyborg can be brain of anybody. Will there be, like we have pets? Why do we have pets? Because we get joy out of pets, right? Not, we fall into love and all those things are second, right? will there be time where we'll tap into all the brains that are out there, which are extremely low cost? So when you do a chat GPT query, it actually goes to those brains and comes back.
Who knows? Yeah, probably. Neuralink, there is Neuralink. There are many companies similar to Neuralink creating hardwired things into our brains. Well, there is also one of the interesting things recently was about how we are developing ability to speak to other species. Um, Last week, there was a very nice piece of work where some scientists actually established a communication channel with whales. Yeah, yeah. So I think it would be interesting to tap into what a dolphin is thinking about, and it will probably have nasty things to say about us, though.
All right, next question. So first, thank you. That was an amazing speech and amazing collection of everything today. I have two disjoint questions. One is on biology, but more on proteins and hacking all the evolution that's happened in sequencing amino acids to do everything that we want to do. I would like your opinion of how you think that's going to evolve. And the second is on the whole thing around fakeness and what watermarks that everybody's promising they're doing in their systems. Is it really waterproof to save, or is it going to go into that chaos of misinformation that you quoted? Two questions. Thank you.
Well, we regulate movies. Children cannot walk into R-rated movies in theaters. So yeah, preventing deepfakes is very straightforward. We put undecipherable messages in e-commerce that powers the entire e-commerce infrastructure of the planet. So the whole deepfake thing is simply a poor engineering, in my view. It can easily be engineered out. And to what was the second question about bio was what? Biohacking? You mean like, can transformer technology be applied to sequencing proteins? Yeah, oh yeah, absolutely. This is one of the amazing things about this transformer technology is how well it does in restricted languages, like programming languages. I was shocked by that. If you had told me back when I first got involved with OpenAI that these things will be so good at writing software, that is one of the shocking things. It does a very good job of writing Python, Java, JavaScript code. Partly because the languages are restrictive, we have lots of examples. Generally, when we write code, there is a lot of common stuff. The same thing can be applied to genome sequences, to protein structures, to molecular structures. I serve on the board of GSK, which is a pharma company, GlaxoSmithKline. And we have, a huge R&D investment in GPU clusters to do this kind of genomic processing, molecule identification. Today, the act of making a drug is basically someone comes up with an idea, and then you try that. So it's very inefficient, and it takes years to get something through. We will soon be, if not already are, at a point where you can hypothesize molecules for particular conditions automatically using transformer technology, and then quickly validate them to see if they are good or not. So like the AlphaFold from Google DeepMind and those kinds of things. Similarly, for genome sequence predictions and so forth, is also something that this technology is pretty good at. So you will see lots of applications in that area. Thank you very much. Oh, one last question. Yes. Yeah. Yeah. I mean, Neeta will tell you, one of the papers that she wrote was on temporal reasoning in AI. Do you remember that? Do you still remember that? That used to be one of our reading in the qualifying exam for AI. And it's a bit disappointing that today's LLMs are pretty bad at temporal reasoning. You can actually easily fool a LLM, one of these big LLMs, into asking about scores of future events. So I showed this live at a BMW board meeting that, asked ChatGPT, or I don't remember which one it was, to write the headlines after Germany beat Italy in the European Cup of 2026. And it had no idea that 2026 is like 2 years later. And it very nicely wrote a headline summary of all the major newspapers and things like that. So yeah, I think basically it's a giant jumble of what is out there. And based on what other people have said, predicting, the next words. And once you think of it that way, life tends to be a lot easier.